Yo, what's up, guys? Welcome back to another video. And today we're going to be talking about another BC topic, aka sequences and series. Since I know that usually around this time in BC, if you have taken AB and you're just going to BC learning new material, I know that around this time most of y'all are doing either Taylor or the McLaren series, McLaren, whatever you want to call it. And I know that soon enough, I think if y'all aren't already onto it, y'all should be learning about sequences and series. And so this is just an introduction video. For me, it's been a long time since I've done this. It's been about like a few good months. And since I'm back in engineering math one, it's been a minute because I forgot this stuff. But I'm gonna try my best to explain this to you. So here we go. Let's say we had a sequence, since that is the base for all series. Say we had a sequence of a sub n. In calculus, and I don't know who came up with this. Like this is just theory. I don't know who came up with this, but in theory, if let's say a sequence of a sub n, let's say it was like 5n over 4n. Let's say we take the limit of n approaches infinity of this sequence. If you're already good and familiar with Calc 1, you should be able to tell that you can really just cancel the n's and you'll just get 5 over 4. But soon enough, this sequence, if we take it all the way to infinity, this sequence converges to 5 over 4. And so essentially, this is our whole building block about sequences and series. All we're looking for in these complex this complex questions, these complex so complex. Like, they look weird at first, but it gets as you break it down, it becomes easier. And here's what I mean. We know this converges to 5 over 4 as limit as n approaches infinity. And so what could we say about that? Well, here is where we're going to be introduced to our first series test that y'all might have heard already. It's called the nth term test. And this is when we add a series. And usually they all go to infinity of n equals 1 of a sub n of something, right? The nth term states, the nth term test, oh my god, states that if we take the limit as n approaches infinity and a sub n is equal to something other than 0, so it's not equal to 0, the series diverges. So an example of that could look like this. The series, the sigma, that's the actual name, n equals 1 to infinity of take the same function, 5n over 4n. Then from here, you just take the limit, and then you'll see that this is 5 over 4. Therefore, by the nth term test, the series of infinity from n equals 1 of 5n over 4n diverges. Reason why that is because due to the nth term test, we can tell that if something is not equal to 0, then it diverges. And that's just as simple as that. So let's say you had another one. Let's say you had series of 3n squared minus 5n plus 1 over 4n squared plus 7. Take the limit as n approaches infinity. And then from here, you just do your calculus and find out that it's just higher power versus higher power. And they are the same higher power. So the limit as n approaches infinity of this sequence is 3 over 4. Therefore, series diverges. So it's just as simple as that. Nothing too complicated yet, nothing that crazy. The second series you'll be introduced to, or probably the first, is called a geometric series. And I think you might have dealt with this back in pre-calculus if I am not wrong. And it usually involves having a series, usually going to infinity, of n equals something with a constant in the front and then you should see this R number here, which is taken to something, something of n, right? By the geometric series, if this number, absolute value of it, is less than 1, it converges. And if it's equal to 1 or greater, it diverges. You might be wondering, well, why did it take you so long to think about it? What's been a minute? All right, chill out. All right, not a genius too. So how do we see this in practice? Well, let's say you had a series of infinity, n equals 0, 5, 2/3 n. How would we apply this is that we would take this number that's being to the power of n, being powered by n, 2/3, right? So if we take the absolute value of 2/3, we can see that it's less than 1. Therefore, it converges. Now, usually on the BC test, I'm pretty sure that if any type of these series, if any type of these series converges, then they'll most likely tell you to get the sum. And you might be wondering, well, I don't know how to get the sum. Don't worry. From here, what you have to do is first you have to get the first term. Because usually this is the formula. You'll get a over 1 minus r, where a is usually the first term. What does that mean? Well, all you have to do is just plug the first number into n and see what you get. So since our n is equal to 0 for the first term, we plug in 5 times 2 to the third to the 0th power. From here we just get 5, because anything to the 0th power is just 5. So from here our first term is 5 over 1 minus our ratio, which is 2/3. And from here you just simplify. So you see that 1 minus 2/3 is 1 over a third. Keep change flip. This whole series converges to 15. And that is essentially why you might be asked to sum the series if it converges. If it's geometric. If it's anything else, I do not know. However, it's pretty tough to get, the summation of something that, is crazy like that, like the purple. The third test you might be dealing with is something called the integral test. So supposedly, it states that, let's say you had a series of n equals 0 of n equals some number of some sequence a sub n. If you were to take the same function or sequence that is inside of here and integrate it from your bounds, it supposedly would give you the same answer. Not supposedly, it will. It will give you the same answer as to it diverges or converges. And here is why I made that other video of the what's it called, improper integrals. Say you had the series of n equals 1, 1 over n. Now, to find if it converges or diverges, you may do another test, but we haven't gotten to that. We'll get into that the next term. Calm down. We just have to do the integral test. So from here, since we know our bounds are 1 and infinity, we just take the integral, and then from here we change up the 1 over n to 1 over x dx. From here we integrate like usual. From here, we find out that this integral diverges because this is infinity minus 0. And obviously, you can't have infinity. So therefore, according to the integral test, since the integral diverges, therefore series diverges as well. And so you might be wondering, well, is there any ever a time where the series does converge? There actually is. Remember how I say check your integral skills? Let's look. This is very interesting. Integral just converges. And you know what that means? Therefore, series diverges. This is essentially the whole idea between sequences and series. You're just trying to see if something diverges. However, it does get more complicated than this. In your classes, usually this is just a quick introduction. So as you can see here, I did the integral of 1 over x squared dx because it is 1 over n squared. That is a sequence function. And then from here, since the bounds are infinity to 1, you just put them in. I did some shortcuts on the way there. Don't worry about it. And then I did negative 1 over infinity plus 1 over 1 is equal to 1. Therefore, the integral converges. Therefore, the series converges. And so here's what I mean by there's another test. And remember, there's some rules here. Say we had an integral of infinity of n equals 1 of something n, right? There's this little test called p-series. And it states that this test can only be used so it's 1 over n to the p of something, when the function or whatever is descending is descending and is essentially to the same thing as this. I forgot all the rules. I am so sorry. Must be descending positive